What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at the interior angle sum of a triangle. This is something that we already know. It's equal to 180. But what we want to do in this lesson is prove using two proofs why it is equal to 180 degrees every single time. So the degrees inside a triangle, no matter what the triangle looks like, is always equal to 180 degrees. It could be right angle, isosceles, scalene, doesn't matter. We know for a fact that the inside angles are equal to 180. But being able to prove this using some of our angle relationships will really help deepen our understanding for this topic and help us find out the interior angle sum of different shapes incredibly easily. So the two proofs we're going to look at today come from two of our angle relationships. The first one is the alternate angle theory, and the second one is the corresponding angle theory. We're going to look at both of these in depth with examples, but I think you're going to find it pretty cruisy. If you do need just a refresher of what these angle relationships are, the last video that I've put up goes into this in a little bit more detail. So all I've got to do in order to prove this is I need to put an extension of the line AC that just goes on forever and ever and ever. After I've put this line down, I'm going to put another parallel line down, but this one's going to go through point B. So these lines are never going to touch. They are just two parallel lines, and this is going to help us see some transversal relationships incredibly easy. So if we just look at points B and A to start off, I can actually make a letter out of these parallel lines and the triangle side that makes it up. This line looks like a Z, and if you go back to our alternate angles, we can actually say that this side of the line on the other side of the B has to be equal to the alternate side of our triangle line. So it's got to be equal to A. So now I've got AB up there, and I can do the exact same thing using this exact same law to know that that little gap there is equal to C. So now I've got angles A, B, and C all on a straight line. Well, we know that a straight line is equal to 180. So that means A plus B plus C has to equal 180 degrees. Just by coincidence, that's what I've got in the middle of the triangle. A plus B plus C. And I said that that has to equal to 180. So that is the proof that the interior angles of this triangle equal 180. This is the same for any triangle. It didn't matter that I used A and C. I could have used B and A, B and C. The same principle comes from this. So as long as we've got that proof down, the alternate angles, you are 100% correct for this proof. So for the corresponding proof, the only thing that I'm going to change, I've still got my two parallel lines, is I'm just going to extend the other sides of the triangle as well. So they're going to come up the top. Now, because I've got a transversal that goes through two parallel lines, I know that the angles are actually exactly the same around these two different points. So I'm going to have a look at point A first. Point A is in this top right-hand corner around that point down the bottom. So if I go up to the top, that means that A has to be in that same position, that top right position. And these two, because they're corresponding, have to be equal to the same number. And now I can do that with my point C as well. So C is on the top left down here. So if I go up to that point B and throw in C in the exact same position, again, I know they have to be equal to one another because they are corresponding angles. But this still doesn't look as good as it could. There's that spot just above or the opposite side of that B. This space is actually equal to B as well, and this is because of our vertically opposite angles. They must be equal to the same thing because they're on opposite sides of a parallel line with some transversals. Again, this means that I've got A, B, and C all equaling up to 180 or that one straight angle. So A plus B plus C is equal to 180. And again, it didn't matter which parallel lines I put in first. This is always going to be the case every single time. So I know this lesson probably didn't blow your mind with anything. Hey, I already knew that a triangle had 180 degrees on the inside. But learning how to prove certain mathematical facts is an incredibly important skill. And it's the foundation for any type of higher level mathematics that you might think about doing. One thing that's going to be really important is we can take this proof, this 180 interior sum, and we're going to extend it into different polygons. So 4-sided, 5-sided, 6-sided shapes in the next lesson. Having this foundation of knowing for sure that a triangle is 180 degrees on the inside is going to make our work much easier in the next lesson. Hopefully you guys come back for that one, and I'll see you later.